Thank you, everyone, for coming along. I'm Julian, and I want to talk about this old open source system called Formalize. That's about Formalize. It's an open source database system. It grew out of consulting work starting a long time ago. And if you've done anything with databases in your career and with clients, you know that they're all kind of the same. Data goes in and data comes out. And that's kind of all there is to it, right? Except that everybody wants their data to go in and out in slightly different ways. And there's permission controls and there's various things that are slightly different. So Formalize, just to give you sort of background about what this is, because I'm going to tell you how we've added lots of DevOps practices to Formalize, but you kind of need to understand, well, okay, but why is that complicated? Formalize grew up out of old content management system technologies, where you got a database behind the scenes and you configure the behavior of the application. And so if you think of something like WordPress, Formalize is kind of like WordPress, but for databases, for all the permissions and workflows and stuff, rather than posts and content. So it's kind of old, as we'll talk about. But so what I want to talk about in general, just to give you an overview. Well, I just told you a little bit, but no one can be told what Formalize is, even though I tried. You have to see it for yourself. So I'll show you a little bit to give you an idea. We will talk about a better future through superior version control. Without good version control, none of what we ended up doing is possible. Teaching an old dog new tricks with Docker, because these days, if you don't have some kind of container involved, you're not really doing it properly. A better future through at least minimal testing. It would be nice to have more testing. It would always be nice to have more testing. For a long time, we had no testing. Who needs testing? Well, it's a good thing. Automate all the things. This is, I think, a key part of any good practice, of course, is automating as much as possible so that you don't miss a step, like leaving the Git folder open to the public and stuff. Anyway, Big Formalize is watching. Talk just a little bit about keeping an eye on things and the future. Future is now, or at least tomorrow, or soon. Future is very soon. So, blast from the past. How legacy is legacy? Talking about a legacy system. What does legacy mean? I've been working in the software industry for 29 years. So legacy could mean a lot. This is the clue. I don't know how easy that is to see for all of you. That happened the year that the Formalize project started. A well-known software company also started in the same year. Don't know if that looks familiar. 2004. So a long time ago, 21, almost 22 years. How did you make web applications in 2004? Was anybody making web applications in 2004 who's in the room? A few of you. So you will know what I mean when I say that's how we made web applications in 2004. We did it with lamps, lots of lamps. For those of you who don't know, LAMP stands for Linux, Apache, MySQL, and PHP, or other similar things. So what did you do? You had PHP and MySQL on the server. That's not too surprising, and we still do today for lots of things, even not legacy things. You had HTML and CSS on the client. Well, obviously, duh. So far, it's not that different. You had JavaScript, but only for UI within the page. You had no JavaScript applications in the client. Nothing like that. Like Google Maps didn't come out until 2005. So, JavaScript was for date pickers and conditional behavior in the page, but that was it. And the app state, because it wasn't maintained by JavaScript in the client, is in the database. It's in the server file system, and it's managed by PHP. And this is also a side effect back then of the fact, I think, looking back on things, it was a natural way to do stuff because, in part, bandwidth was expensive and latency was very high. So the way you do things now with tons of little requests going up to the server, just you couldn't have written an application like that even if the technology existed. Now, in our case, especially, every instance of Formalize, when you install Formalize on a server, every instance immediately becomes distinct. So it's not like you're installing the app and then you can refresh the app with the latest version. Like once you install it, you're off on your own because of the database, the configuration that goes into the database, and because of various changes in the file system. There's also no package manager. There's still no package manager in Formalize. It's all just one set of code. And version control is really hard in 2004. A lot of people are still using CVS, never mind SVN, and Git hadn't been invented yet. So version control was tough. And that's also why I think a lot of stuff focused on the database. We put more stuff into the file system now than we used to. We used to put everything in the database. Any code customizations in the database. Everything goes in the database. Because managing changes to the file system was hard. So you stick it all in the database, and then you grab a database dump. And then you've got the state of the application. And you're happy, except having the state of your application in the database is really difficult if you want to do anything like modern DevOps, right? So that's the situation. What do we do? Well, so suppose you have a server somewhere. You should all come up to the front if you want to see that. Anyway, feel free to move. That's fine. I got to stay here because the camera, but you know. So imagine you have a server somewhere. I mean, you could these days. What would be the optimal way is you set up the webroot folder on the server where you want it, and you git clone the repository, and whoop, you've got all the files. That would be easy. In 2004, you'd use FTP. I mean, you can do anything you want to get the files on the server. Doesn't really matter how the files get there. They got to get there somehow. But doing it all through Git makes things very simple, at least today. Now, if you do that with Formalize, what happens? Like I said, no one can be told what it is. You have to see it for yourself. Hopefully, you can sort of see that even at the back. What you get is you get the installation wizard screen. If you remember the old days, if anybody ever installed WordPress or something like that from scratch in the old-fashioned way, you'd go have this installer, and it would ask you various things, and then basically it writes a configuration file somewhere that stores, you know, your name of your database and the credentials and so on. And that's how it works. So we have a similar sort of thing. You install Formalize to begin with, which is the beginning of customizing your instance to be your special instance that's distinct from the master repository. So one of the things we do in the installer is we have to make sure all of these places are writable because we're modifying the file system right off the bat. So the installer checks for that. You go through the installer, you do all the stuff, like I said, and eventually installation completed, yippee. And then you have a login page at the home page of your website. And if you log in, you have nothing. Formalize starts empty. Think of it as like WordPress with no blog posts. It's empty. Now, what do you do with Formalize? Like I said, it's a data management platform. So what you do is you go into the administration side, because there's like a front side for users, and there's the administration side for webmasters, you know, similar to a lot of applications. And you hit the giant create a new form button that we used to be kind of hidden, but we made it really big now when there's nothing there, so you kind of know what to do. So you create a form. So a very simple demo application I like to do for people is provinces and cities. The simplest kind of database you could do. Provinces have many cities. You got two tables, a one-to-many join, and so on. So in Formalize, you'd set up a form called provinces. You'd add another form later. You'd end up with two forms there, cities on top, provinces below. And you'd say each province has many cities. And you'd specify the elements in the form that connect that do the joining, and so on. And this is kind of the essence of the whole idea of Formalize, because really it's designed not for developers or not just for developers. It's designed for the clients. It's designed for end users in an organization. Just like, again, I keep harping on WordPress as an analogy, but, people who aren't web people can have a blog on WordPress because they post things and there you go. And people who aren't database people could build a database and Formalize and manage it. And this is intended for small to medium-sized organizations, nonprofits, where they don't have a big IT team. They have some particular process. They know how the process should work. If you've ever done consulting on data management, you know that the clients know all kinds of stuff, even things that they don't know that they know, and they keep revealing little bits of it as you go along in the engagement. And eventually you get the whole picture of how this thing should work. But they sort of intuitively understand all of that. And so if you give them a tool that they can describe what they're doing in the language that's meaningful to them, instead of all this technical mumbo jumbo, and they don't need to do any programming to make it happen, then they can manage entire complex systems all by themselves. And there's examples of that I could talk more about. But anyway, so that's what Formalize is and does. What you end up with here is a province form. It just, the UI, the front end just gets created out of the configuration that you've made. You can fill in, Quebec has a bunch of cities, Quebec and Ontario and so on, and da-da-da-da-da. So you've got your database. Once you've done that, what happens on the server? So over on the code side, if you're doing it through Git these days, you should make a new branch, because obviously you're not going to take all your changes and push them back into master. So make a new branch. You immediately then have a bunch of changes that you need to start recording. One of them is the quote main file, which has the path for various things. There's also this file called install lock that we added, and you have to force it. I keep looking at Arvin because everything I'm talking about is actually Arvin's doing. When Arvin started working with me on Formalize a few years ago, he's like, so can I download a container? What's a container? I knew what a container was, but no, we didn't have a container. And so on. So, it used to be that we delete the installation folder from the live systems, because why do you need it anymore? But the problem is when you start doing serious version control, you then have lots of merge conflicts because you've deleted this folder, but the master repo still has it. So then when so Arvin had the brilliant idea, well, let's just keep the install folder there, and we'll just put this little lock file in the root. And if the lock file is present, we just bypass the install folder, and that's it. It's like, yeah, okay, that's easy. But we ignore it in Git, so you have to force the include if you want to include it. Anyway, whatever. I guess you wouldn't have to include it because it would still be present in your file system. But the thing is, if you checked it out locally, you wouldn't have it, and then you go to the installer again. And there's various other things related to the database and stuff. But yeah, we don't have a lot of time to explain everything in minute detail. So then you could make a commit, initial changes, post-install, and you've got a history of your unique system. Wonderful. Okay. You'll see how relevant that is as we go along. Now, before Git, what would you do here? You just have a bunch of files on a server that are different than any other set of files you've ever had anywhere. And if you ever want to deploy anything new, then you better get good at doing diffs yourself and copying changes and stuff. If you're in Windows, WinMerge, let me tell you what you can do with WinMerge. It's awesome, and it's open source. I think it's open source. It's at least free. Pretty sure it's open source. I have a strong bias towards open source. Formalize is completely open source, is GPL2. Everything I'm showing you is, like, you check out the Formalize repository, you'll have all the YAML files, all the Docker files, like everything. It's all open source. Okay, so in the beginning, you've got your website set up. It's custom, it's distinct. You might change the theming and the styling. You adjust various things. You add your own custom form elements. You can write class files and Formalize if you have a unique element that you want to add to the form, or an element with unique rules for validation or for whatever that's unique to the workflow. You can just make up your own elements. You write a class file, and there you go. You might alter the default templates because there's a default way that the front end lays out, but you put in a different logo, you change the colors, you do whatever. And hey, it's open source. You might fix bugs, you might hack stuff, you might do whatever. I mean, the whole point of it being open source is that you can do that if you want to, or if you need to. So you certainly might. You're not forbidden. And if you do, then your code base is diverging further. And then something like this happens. Formalize 8.1 earlier this week, with even more AI integration than we have before. It's awesome. We have an MCP server built into Formalize now. So any Formalize application that you make is completely AI enabled. So you make an inventory system and you want to talk to the AI assistant about your inventory, or do data entry of all these new things, give the AI a spreadsheet and it'll just do the data entry into your inventory system. Whatever you want, or if it's activity tracking or surveys or timesheets or any data application you make in Formalize, fully AI enabled off the bat. And it actually works phenomenally well because everything in Formalize is configured at this semantic level of like each province has many cities. So when the AI reads the configuration, well, it's a large language model and everything's described in plain business logic language. So the AI is like so on the ball with you add a new form. It's like, oh, you added a new form and I see that it's a great addition to this and this and this and this in your system. Like it doesn't have to interpret your technical configuration through all these layers to realize what you're doing. So the MCP in Formalize is kick-ass. So you're like really excited, but you want to update your site with all these distinctions to Formalize 8.1. What do? Well, if you've been following along in Git, this is why superior version control is the answer to a lot of problems. Then you just do git rebase on master. Yay! You've got all the changes. Works. Lovely. Now, that's not what we generally mean by DevOps. There's more to it, and we'll get to that. But that's a really fundamental, important part, is that you can easily manage the code base now. Before Git, well, I mentioned WinMerge. Like before Git, yeah. Before Git, things are hard. Okay, local development environment. Key part of any practice. Client calls you up, site's broken, this doesn't work, I did this, the form froze or whatever. You're like, oh crap. So what do? FTP to the production server and start hacking files to figure out what the problem is? Been there, done that. It works fine if you just wrap everything in if statements and say, if user is admin, print out all the variables. Thanks. You can do it. And you really learn a lot of discipline when you do things that way. So everybody should, because it, blah, blah, blah. No, you should do it locally. First thing Arvin did is like, how do I spin this up locally? It's like, well, you install Apache and MySQL and blah, blah, and you copy the files, and then you can run it locally. And he's like, that's bullshit, man. Okay, so what do you need? You need, of course, the exact and complete live site code base, which you now have in Git because you've been following along. You need the current database because the fact that you have a province form and not an inventory form lives in the database because all the configuration goes there. And you need to easily set them up in a LAMP environment, not have to copy things into the web root of your local Apache or whatever. Site-specific code mixed with application code, like that general situation, that's why we cannot build a container, a contained application container, like a single thing, like just, you can't just sort of install Formalize, like the canonical Formalize from Docker and away you go, because you need that code base and you need the specific database. So what's our solution? If we can't have like a Formalize container that you can just instantiate and run, let's just turn every Formalize system into its own container, like add Docker to Formalize itself in the code base. So every system becomes potentially a containerized application. So we have a Docker compose and a Docker file in the master repo. And this is the magic part. If you're very familiar with Docker, this might seem obvious, or you might have done this kind of thing before, or at least it'll make sense when I say it. If you aren't familiar, you may not understand it at all. We have to keep going because it's a short presentation, but I'm happy to chat in great detail with anyone after. You map the Docker web root to the repo root directory. So you have a generalized Docker container, except like our Docker file and Docker Compose. It sets up, Apache and everything, but it's empty. And then we map the web routes to your actual file system where your repo is. So then your site becomes the site that's inside the container. And you persist the database in a volume in Docker. Or if you're doing this for the first time, you stick a SQL file in the seed folder, and when the container is booting up, it's just going to it's going to run the SQL file and generate your database. And away you go. Database, we used to mount it from the local file system. So you'd have like a folder in the file system, and that would be where the database lived. But there be dragons, do it with a volume. Because the volume exists inside the container environment. And so you don't end up with case sensitivity inconsistencies between operating systems if you're not using the same operating system as the host as the container's using. So anyway, now you can spin up any site at any time. It's wicked. Docker Compose up in your repo that you've been maintaining, and whoop, containers created. And you get there's your thing that you probably can't see on the little screen, but there's your provinces form with Quebec and the 3 cities, but it's running at localhost. So there you go, just like that, automatic. And you can do this for as many sites as you want, because you just make a new folder and check out another site and Docker Compose up, and now you've got 6 containers instead of 3, and you do it again, and you got 9 containers instead of 6, and you got 3 sites running. The one thing you have to be mindful of is, by default, they're all going to try to run it at 8080. So you adjust the port numbers or whatever. So what does that actually look like in practice? Here's our Docker Compose. So a custom container was made with all the necessary PHP in place to set up everything, plus Xdebug and so on. So we did make a container for that. It just doesn't contain the formalized application, which is, that's the part that mounts it from the web root, mounts the repository as the web root of the container. And the database goes into the seed file or the seed folder, and then just gets sucked up and the volume persists. You still need to be mindful of the trust path, which was one of those original things that we committed. There may still be some subtle differences, and because you don't want to be doing things like committing your database credentials to your repository. So you have to adjust certain things that are going to be different between your local and the remote, but it's very minor what you have to tweak to make that work. Testing. No unit testing, sorry. Lots of E2E testing though, and it's actually getting fairly slick what we can do. Because the database is key to functioning, for formalized functioning, unit testing any significant behavior of the application is a challenge. You could unit test all kinds of little functions, but because it's legacy code, some core parts of the system are not little functions. They're very big, ugly things. That's that's getting better. But the older parts of the code base, not written in a way that's conducive to unit testing. But we did have a whole bunch of old Selenium tests for one particular formalized site, a long-standing client, and we had some Selenium tests for them. We rewrote those in Playwright. Ask Arvin why. Playwright tests live in the formalized repository, so they can run against your locally instantiated Docker containers. Playwright is also very easy to get working with GitHub and GitLab CI pipelines, so you can see where we're going with this. Tests run sequentially against the URL, usually your local host, because you spin up that container, you've got localhost, so your tests run against there. Now, in our case, first test runs the installer, next test makes forms, after that, tests enter data in the forms, and so on. There's no parallel tests. This is what the tests look like. Number 1, install, then create the users and groups, then do the forms and the elements, then set all the permissions and create the menu entries, then do the data entry, validate it, and check that the MCP server is running. So that all happens in order. Like, you can't do the data entry until you've created the forms and so on. And that's probably true for a lot of, well, that's true for some functional tests. There might be other situations where you just run a whole bunch of things in parallel because they're each atomic. But essentially, we have dependencies between our tests. That's the bottom line. And this is the subtle part. We have references in the DOM to the ID numbers of specific forms and entries. So the selectors in the Playwright, when it's going through, for those of you who don't know Playwright or Selenium, this is like basically JavaScript interacting with your UI, simulating what a person would do. So there's selectors for things in the DOM, but we have to make sure they're generalized because you don't know when you're running the tests if like what the internal ID numbers are going to be. And I got some examples of that after this. Also, Playwright can be flaky. Or wait, is our application flaky? Maybe it's our application. Things that work fine for a human in the UI might not work fine when everything's happening in 12 milliseconds. So you really have to start taking that into account. And I got some examples of that too. Playwright really can be flaky though. If you have like a lot of JS doing stuff with the DOM in those 12 milliseconds while Playwright's trying to do something, you can just get weird interaction effects and stuff. So you might have to do some creative workarounds. Some examples of things we had to do that are a little unusual. So there's a save button at the bottom of the form, but if in Playwright you hit the save button and carry on, bad things happen. We have a whole function called save formalized form that does a bunch of stuff to make sure that, number one, you're able to save the form at this millisecond because some things might not have happened yet that need to happen, and that there's no saving operation still completing and so on. So like we have this, you may need to create essentially semantic wrappers for behavior instead of just triggering it with a click. Yeah, can't just click the save button because lots is happening behind the scenes. And we need to pay attention to that before we can continue. Here's an example of the selectors. Hopefully you can see that. This one is like filling in a box in a form. It's form 2, new entry, element 21. Well, depending on the state of your database, like this form, it just might have different numbers. If you want this to run at any point in any time, no matter what, you want to do it more generally. So the div with this name thing, which is the name of the element, that's what you want to interact with. And nothing that's going to be dependent on the runtime of the database. Very funky stuff too. You might end up doing like, figure out this table in the page, look at the rows of the table, and then for the first, second, and third row, do various things. And so you can get kind of interesting. And then what about this? What's going on here? Well, in this case, we don't know. We prefer to use /survey to reach this page because that's obviously going to be generic. But we don't know if the URL rewriting works, and the underlying URL for the page is going to be modules, formulas, index, screen ID, something. But we don't want to use the underlying address because it has an ID in it. So we hope that the rewriting works, but we have all this if and try catch, because if the rewrite didn't work and we can't access it on that the general address, we go for the screen 9 address and hope that screen 9 exists. I'll skip that because that just shows you a bit about what our test application looks like when it's finished. I can show you that later if you're interested. Continuous integration of the tests. So that's great. We got tests. You could run them locally. You trigger them. Yay, they passed. But continuous integration with testing is the real secret sauce. So again, a little small unless you're at the front. But we have a YAML in GitHub that basically checks. We have a little skip test instruction you can put in the commit message, just in case you don't want the tests to all run, because you might just be doing like fixing a typo or something, and who needs all the tests to run? This was an idea that I mentioned to Arvin at the beginning, or before as we were deploying this, and it seemed like a good idea. But have you ever used skip test? I've never.
The idea.
It's a great idea. That's what I thought. Except I've never used it, and I don't know if you've ever used it, but yeah. Yeah, it's like, oh, just test everything, all the tests, So if we're not skipping the commit, then GitHub checks out the repository, They set up a virtual Ubuntu environment with PHP and everything already there. They check out our files into that environment, and then we set up, writable permission on the right folders, and then we do a Docker compose up. So we have our local dev environment that we created running in the virtual GitHub environment, and then GitHub installs Playwright in its Ubuntu and runs the tests. So we've got like virtual Ubuntu with our virtual containers in it. It's like Inception. It's like containers all the way down. But it works. And at the end, you can see the results easily. This one failed. Yeah, we can see the results. We can download the details of the whole test run, including screen recordings. You can see all the tests, and you can see videos of what they looked like when they ran. Even though it's in this virtual environment, in a virtual environment, you can take a peek at what's going on. This one failed. It was actually a test bug, not a code bug, because a new test that I added altered a certain value. Later test was still asserting the old value. Test failed. So testing, sometimes it creates headaches, but it's overall worth it, right? Semi-automated deployment. What I showed you was GitHub, but what about client sites? What about live real sites? Not just testing the formalized code base. So this is a more complicated one. It has a build job, a test job, and a deploy job. So the build job, we SSH from GitLab. We don't do this in GitHub. We do this in private repositories in GitLab. So we SSH from the GitLab container because it's spinning up some virtual environment just like GitHub. But we just use that as sort of a point to launch some scripts. And we SSH to the staging server of the client. And we check out the target branch that we want on the staging server. Because we can't automate this stuff on the staging server directly. So we automate it in the code repository in GitLab. And then it just SSHs to the environment and does the things. Then we run our E2E tests. We have site-specific tests for this client. So the formalized tests have already run, like with every check-in on the formalized code. And then when we're deploying things to the client-specific tests are running. So we run those tests. Again, it's inside the GitLab container that Playwright is running. But the target URL, instead of being localhost, is the staging server. So it goes and runs all the tests against the staging server where we just checked out the code that we want to deploy. And assuming the tests pass, it unlocks the deployment step. And then we SSH the production server for the site in question. And basically, it's like the build step. We SSH, we run a script. And the script more or less boils down to git stash, git pull with rebase, and then git stash pop. And that's it. That's the deployment cycle. Stash? Git stash? Wait, what's going on? So formalized systems write stuff to the file system during normal operation. So at any given point, the client could have customized a template, could have done something that modified the state of the file system on the actual server. So when we deploy from GitLab, we are careful not to clobber those changes or create merge conflicts or whatever. So we stash, and then we pull with rebase, and then we unstash anything that they might have been doing. And this is the funky magic part. Very simple. We run a nightly cron job on the production server that pushes any local changes to the site's repository. And that is so that our canonical repository is up to date within the 24 hours of what's actually going on the production server. And that's so that if you need to do local development on something, you can just check out the repository and you've got the state of the server as it was, at least as of last night's push. And that's a screenshot there of like the history on this repository. It's like automatic commit from production on the 13th, the 11th, the 8th, the 7th. So it's just updating the repo with all the local stuff. Yeah, and ensures we can check out the repository locally and do Docker compose up, and there you go. You also need a dump of the database. You do need to get that. Yep. Mhm.
What branch does that go into? Not main.
Not the formalized master, but it goes into whatever the site. We have a branch for each client site, basically. So it's going into like their branch. Well, yeah. 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 Yeah, that's a good point. Each client has its own repository. Within that repository is their specific deployed branch. And then we periodically rebase that deployed branch on the formalized master, and it's getting the nightlies from the production server. So it's always relevant and accurate. Logging. Good timing. Logging. JSON objects written to a text file. Yeah, we didn't have any serious logging. There was whatever was logging on the server, but like whatever. We added comprehensive logging so that we could see what the heck was going on when people call and say, this weird thing happened. And it's like, oh, well, did you get a screenshot? What were you doing? Oh, I don't know. Users are, terrible at reporting stuff. So look in the logs. We set up each line of the log as one log entry. Each entry is a JSON object, and the format is standardized. So like every line is consistent in structure. They don't all have every field filled in because not all the fields are relevant. Depends on what the log event is, whether that field is relevant. And so this made it easy to scrape all the log data into Grafana Loki we set up for this particular instance. The logs look like that. Time, what the event is, session loaded, attempting to render something, saving data, update entry, load the session again, render the form screen, render the form, completed the page rendering, and so on. We got the request IDs from like Apache. We've got the session IDs that represent the user, and the user internal ID within Formalize, the form ID, the screen ID if it's relevant, the entry ID in the form that was being interacted with if there is one. Like there's no form, screen, or entry for loading the session because they're just sort of instantiating. We're instantiating their identity, but we aren't interacting with the form yet. We got the multiple, session loaded, because 2004, every request is brand new. Cookie goes up, session gets loaded. Yeah. You can cross-reference with the server logs because we have the request ID there. So you can cross-reference with the Apache logs for given request ID. You get the whole picture. What were they requesting? What was the payload to the server? And then we have the whole history of what did Formalize do in response to that, and so on. And we keep the logs for 7 days. Whoopee. The road ahead. A production-ready Docker container. So each web server with Formalize is its own environment. There would be many advantages to being able to deploy a standardized environment instead of just, through Git or FTP or whatever, putting the application code there. Move everything into files. We've already been doing this. We used to store custom templates and everything in the database. Like I said, very little interaction with the file system. Still some, but minimal. Now we have much more interaction with the file system because we want to get it into version control. And we're going to keep putting as much as possible out of the database and into the file system for that reason. Configuration as code. We've been working on representing the entire system configuration in JSON files. So that way we could version control the config. Instead of just having a database dump with all your forms and all those settings, we could actually have that represented in a file, and then it could be version controlled for changes and so on. And we won't essentially need the DB dump. If we have a complete configuration in the file, we won't need the DB dump to instantiate because we could just essentially bring the database to life by seeding it with the config. And then you don't need that database dump anymore. And that will also potentially allow for portable apps. If we manage the primary key, foreign key dependencies in the database properly when we synchronize that config into the database, then we could export your provinces and cities from one system, which is form 1 and 2 in what we just did, And we could just export that, and we could import it into another system where it might be form 55 and 56. But everything would just work if, because there's references, like at a very simple basic level, the elements all reference form 1 if they're part of form 1 or form 2. You move them over here to form 55 and 56, well, all those references have to change. And that's just the beginning, the tip of the iceberg. All the configuration throughout the whole thing has all these foreign key references all over the place. But if we can manage that in the configuration when it's exported and imported to generalize it, then formalize app bazaar or a commons or something, it would not be an app store because this is open source. So it would have to be an app bazaar with camels or something, but it'd be cool. So I think there's a few minutes for questions.
I think it's-
Ta-da! That's it.